Hi and welcome to Maths class. Today we're looking at the antiderivative of ax plus b raised to the power of r. Now in our last video we looked at power functions x raised to the power of r and we noted that r was not equal to -1. So today we're going to look at the case when r doesn't equal -1, and then afterwards we're going to look at the special case where r does equal -1, and that'll be in the next video. So case 1, r does not equal -1. What we're going to start with is a bit of revision of what we know of differentiation. So if I say that capital F of x is equal to this function, that is ax plus b raised to the power of r plus 1, so that's a linear function raised to a power, then when I differentiate it, I need to use the chain rule. So first of all, I take the power and I multiply it out the front. So I'm multiplying by a factor of r plus 1. Then I need to take the derivative of the function inside, because this is a composite function. It's a linear function raised to a power. So the derivative of ax plus b is a. And then I need to subtract 1 from my power. So r plus 1 becomes r. So the derivative, capital F dash of x, is a times r plus 1 times ax plus b to the power of r. So if I take that in reverse then, that means that the antiderivative of this function must be capital F of x, which is what I started with. So let's look at that. The antiderivative of a times r plus 1 times ax plus b to the power of r with respect to x is equal to ax plus b raised to the power of r plus 1, but now I need a plus c because there might be a constant added to the end. So if I now bear in mind that this a is a constant number and also this r plus 1 bracket is a constant number, then I can take those out of my integral, a times r plus 1 multiplied by the antiderivative of ax plus b to the power of r dx, and that will still be equal to that right hand side, ax plus b to the power of r plus 1 plus c. But I'm not looking for this entire thing. What I want to know is, what is the antiderivative of ax plus b to the power of r? So what I'm going to do now is simply divide both sides of the equation by this constant factor. So I end up on the left-hand side with ax plus b to the power of r dx, and on the right-hand side, I divide by the constant, which is a times r plus 1, and then I still keep this part of the right-hand side, ax plus b to the power of r plus 1. Now, I still need a plus c. This c is actually different from this c. So what I might do is I'm just going to call these ones c1 and I'll call this c2, but it really doesn't matter because c stands for an arbitrary constant. So it doesn't matter if I then divide c by a number, I've still got an arbitrary constant. So what this leads me to is this rule here. The antiderivative of ax plus b to the power of r is 1 over a times r plus 1 times ax plus b to the power of r plus 1. Now if you look at it, this is really similar to what we did with power functions. Remember that the antiderivative of x to the power of r dx is simply going to be 1 over r plus 1 times x to the power of r plus 1. So if I've just got a power function, what I needed to do was add 1 to the power and then divide by the new power. So I've added 1 to the power and divided by the new power. I'm doing the same thing here. I'm adding 1 to the power and I'm dividing by the new power, but I also need to divide by the coefficient of x inside, which is in fact the derivative of the function inside. So let's do one worked example. And the worked example that I'm going to look at is this one here. I'm going to anti-differentiate 4 times 5x minus 2 all cubed. So let's look at that. But there's not quite enough room on that sheet. I'm going to write it on a separate page. 4 times 5x minus 2 all cubed. So anti-differentiate, I need to remember my notation. I need the integral sign, and then I write my expression 5x minus 2 all cubed dx, and that's going to be, so let's remember my rule. I need to divide by the coefficient of the linear function inside, so that's times 1/5. I also need to add 1 to the power, which will make it 4, and divide by that. So I'm also going to divide by 4. That's going to be on my denominator as well. Now, I've got this constant here. I don't want to lose that. So let's make sure that I keep the constant in my numerator. And I end up with, I keep the same linear function, but my 3 becomes a 4. I add 1 to the power, and then I plus c. Now I can simplify this. I've got a 4 on the numerator and on the denominator. So they will cancel out, and I'll be left with 1/5 times 5x minus 2 to the power of 4 plus c. Okay, for case 2, we'll go to the next video.